This is the second part of the chapter, Shape and Space 4. You can see the page number 276, we have exercise 2. Here we have to calculate the angles. Here in a right angle triangle, two sides, the measurement of two sides is given and we need to find the angle. Now you can see we have sine, cos and tan. Sine, these are the trigonometric ratios. Sine is opposite by hypotenuse and this is adjacent by hypotenuse, this is opposite by adjacent, that we have explained in the first video. Now try to understand, if I will take the angle theta, then sine theta is opposite by hypotenuse. And we can see here are three values, three variables. One is this, second one is this, and second one is this. How many? Three variables. If we know the two, we can find the third. If we know the two values out of the three, we can find the third easily. For example, I have to find the theta. Then what I should do? I will write theta is equal to sine inverse opposite by hypotenuse. This inverse we will use when calculating the angles of right angle triangle. Now you can see, similarly, if sometimes adjacent and hypotenuse is given, then what we will do, we will take the theta is equal to cos inverse. And when opposite and adjacent is given, we can take the theta is equal to, or x is equal to, or whatever the angle is given is equal to tan inverse opposite by adjacent. Then we will use the calci and we will calculate this value. Here we go, the exercise 2, the question number 1. Here it is right angular triangle like this, and this side is 4, this side is 3, this is theta. First read the question. Give your answers corrected to three significant figures. Find each angle marked theta. So we should write the answer corrected to three significant figures. You can also see the video on the significant figures. I have made the video on the significant figures. There you can clear the concepts if you have any doubt while writing the significant figures. So here we have to find the angle theta. Now you can see, first always identify the sides, which is adjacent, which is hypotenuse, which is opposite. This side, this angle is 90 degree and this is the longest side, so this is hypotenuse, and this side is opposite to theta, this is opposite. Now you can see from the diagram, this is opposite and hypotenuse, and I have written here sine is opposite by hypotenuse, so I can directly write sine theta is equal to opposite by hypotenuse, that is 3 divided by 4. So theta I can write sine inverse 3 divided by 4. So here you can see theta is 48.6 degree. Now see the question number 2 from the same exercise. This is the diagram. See on the textbook, you can see the diagram like this. Here it is 90 degree angle. And here you can see opposite to this side, this angle is the side which is hypotenuse. That is 12. It's given in the question. And here this side is given, it is 9. So this is adjacent to this theta. Okay, now you can see adjacent and hypotenuse. First thing is to identify the sides, whether opposite, adjacent and hypotenuse. So here adjacent and hypotenuse, you can see adjacent hypotenuse is cos. So I will take cos theta is equal to adjacent 9 divided by hypotenuse, that is 12. So theta is equal to cos inverse 9 by 12. Theta is equal to, on calculating it, we will get theta is equal to 41.4 degree. Now see the fourth one. The diagram is like this, figure is like this. You can see this is the right angular triangle and this is this opposite side to the right angle. So here it will be the hypotenuse and this side is what? It is adjacent. Once again we will use the cos theta is equal to adjacent by hypotenuse. That is theta is equal to cos inverse of these values. 3.7 divided by 11.5, and you will calculate on the calci, you will get it 71.2 degree. See the question number 7. A small coin is thrown up the Eiffel Tower in Paris. It lands 62.5 meter away from the center of the base of the 320 meter high structure. Find the angle of elevation from the coin to the top of the tower. So what actually is this? The Eiffel Tower. From an Eiffel Tower, there's an Eiffel Tower. A coin is thrown from the Eiffel Tower. For example, this is here the Eiffel Tower at some distance. From the top of the Eiffel Tower, the coin is thrown, and there's a structure in between this that is 320-meter high. So we have to deal with this only. This is 320-meter high, and the coin falls at a distance of 62.5 meter from this building, from this structure. So this is one of the structure, 320 meter. Here the coin falls here, and here the distance is 62.5 meter. Here this is the angle of elevation. You can see this is the horizontal, and this is the sight, line of sight, and here we can see this is the angle of elevation. We need to find this. If you will check, this is the right angular triangle, and this is opposite, and this is adjacent. You can see here it is tan. So I will write directly tan theta is equal to opposite, that's 320 by 62.5. So I will write theta is equal to tan inverse 320 divided by 62.5. Once calculating on the calci, you will get its value, that is 78.9 degree. That is theta is equal to 78.9 degree. So we can say the angle of elevation is, therefore angle of elevation is 78.9 degree. Now you can see, see the question number 8. We have a rectangle has a side of 10 meter. There's a rectangle and its one side is given 10 meter. But we don't know whether this is longer side or shorter side. And the measurement of diagonal is given 25 meter. Now how to check whether this is the longer side or this is the shorter side? You can see here, this is right angular triangle. This is the triangle here. Here the two sides are, one is 10 meter and other is 25 meter. For example, I am considering it is less than 10. That is, for example, 9 meter. Then you can see 10 plus 9 is 19, which is less than third side, 25. Understand this. So here the sum of the lengths of two sides of triangle is less than the third side. This contradicts my result. We have a proven result. In a triangle, the sum of lengths of two sides is always greater than the third side. It should be greater than the third side. It is here less than. So we can conclude here, this is not the shorter side. This is not the shorter side. Definitely this should be the longer side. And it should be greater than 15, so that the measure of these two, the sum of lengths of these two sides will be greater than the third side. So I can say this is not the longer side. This one. This is the longer side. So I need to find the angle between the longer side and diagonal. That is this angle. Now see here from this triangle, this is hypotenuse and this is adjacent, opposite. Now you can use sine theta is equal to opposite, that's 10 divided by 25. So you can write it is 2 5 2s are 5 5s are. So you can write theta is equal to sine inverse 2 divided by 5. Then you can calculate this on the calci. On the calci you have to calculate this. How you will calculate? You will have to calculate on the calci. We have here sine inverse 2 divided by 5. That is 23.57, and we are going to write it up to 3 significant figures. That is 23.6 degree. So this is the required angle what we need to find. So I can write, finally I can write the angle between the longer side and the diagonal is angle between longer side and diagonal is 23.6 degree. This was question number 10. Question number 8. Sorry, it's actually the question number 8. Now you can see the question number 9. In the question number 9, it is a train travels at 20 km per hour for 15 minutes. So what is given in the question? It is traveling 20 km per hour for 15 minutes. So here speed is this and time is 15 minutes. We can convert it. 15 divided by 60, that's 1. 15 ones are, 15 fours are, that's 1 by 4 hour. So speed is in kilometer hour and time is now 1 by 4 hour. How to find the distance? You know, speed is equal to distance divided by time. So speed into time is equal to distance. So I can find the distance is equal to, what is speed? 20 into, that's 1 by 4. 4 ones are, 4 fives are. So it is 5 kilometer is the distance traveled by the train in this unit, in this time. Now you can see from the question, a train travels at 20 km per hour for 15 minutes along a straight track inclined at theta degree to the horizontal. So this is the horizontal. Now train is traveling like this. Here you can see it is attaining the height of how much? It's 150 meter. This is here the theta. Now you can see here the speed of the train is what? 20 km per hour. Once again I will write the solution. So I will write like this. Speed is equal to, I will write distance is equal to speed into time. What is speed? Speed is 20 into what is time? Time is 15 divided by 60. Why? 15 is minutes. I am converting into hour actually. So that's 1 divided by 4. 4 ones are, 4 fives are. So it's 5 kilometer. So I can write here, when it is 5 kilometer, here I have 150 meter. I will convert in meters. 5 into 1000 meter. So it is 5000 meter. So here this side is 5000 meter. Understand? Here I am calculating the distance, that speed into time. Speed is 20 km per hour. But time is given in the minutes, so I have to convert it in hours. How I am converting? I showed you here how to convert 15 divided by 60. That's 1 by 4. That's we got 5 kilometers. Still we have here 150 meter. Now we are calculating, we are changing this kilometer into meters. In 1 kilometer there is 1000 meters. That's why I am multiplying here with the 1000. I got here 5000. Now you can see for this theta, this angle, this is opposite and this is hypotenuse. So how to find the theta? I will write directly theta. Opposite by hypotenuse is equal to sine inverse. What is opposite? It's 150 divided by 50,000. Now you can see, you can use the calci and on the calci you will get the answer. What is it? It is sine inverse 150 divided by 5000. It is 1.72. So how much is 1.72 degree is the angle that is made by the horizontal with the train, or we can say it is inclined at an angle of 1.72 degree. You can see I am writing here the answer corrected to 3 significant figures. Remember these things. Now see the question number 10. A toy plane attached to a 15-meter wire is flying in a horizontal circle of radius 5 meter. From the diagram you can see this is actually the 5 meter here. It is the radius. Now this is the wire. It is 15 meter and we have to find the measure, the angle, this t degree. How to find this t degree? You can see this horizontal and this line, they are parallel to each other. So this angle will be also the t degree. Now you can see this is here the right angle. This is hypotenuse, and this side is for this. This is adjacent. So adjacent by hypotenuse, that's cos. So I can write cos t degree is equal to Adjacent by hypotenuse, that's 5 by 15. That's 5 ones are, 5 threes are. So I can write here t degree is equal to cos inverse 1 by 3. Now calculate the cos inverse 1 by 3 on the calc. You will get the answer, which is 70.5 degree.